Hello everyone, how's everybody doing? I hope you're doing fine. We got a great day today, and I'm going to start out with some of the fan mail. Okay, I'm going to get into Brian Greene later on, but first I'm going to handle some of the mail that came in. And here's the first issue comment made by someone, or question. If light is an object and travels through air at a speed of roughly 300,000 kilometers per second, then why doesn't it create shock waves all day when it is present? Okay, well, for this, I can only give you the hi Tesla. I can only give you the rope model version of why. Okay, no shock waves, and for this you got to understand what's being proposed. What's being proposed is that instead of discrete particles, as mathematical physics would have you believe the subatomic world consists of, or the atomic world is including the atomic world, the rope model proposes that all atoms are interconnected. Okay, that means that they are physically interconnected, and so what it does is an atom pumps and sends light along each one of those connections, which is a rope-like mechanism. Looks like DNA. In fact, I venture to say that DNA got its model from the electromagnetic rope. Okay, and here is what it looks like. Okay, you have two atoms pumping, doing their quantum jump. When they do so, they torque the rope. Okay, and it's that torsion along the rope that we perceive as light. Okay, we have an atom in our eye, and it receives that torsion, and it begins to pump, and that's what we sense as light. And those two threads that form the rope, they also construct the atom. Here's the construction of the atom. If you give it a second here and it starts again, you'll see the ropes ending at the red circle there. That's the electron shell. And here you see it, the electric thread from every atom in the universe goes through the atom, out the other end, and a magnetic thread coils around and forms an encapsulating shell. Okay? And all the threads coming from every atom in the universe construct our atom. Okay? That's what the atom looks like. And so, yeah, when you have this model, okay, then there are no shock waves, because now you're talking about what is the physical object that is waving when you're talking about shock waves. Okay, so light would have to, for example, disturb the air, for example, and make it vibrate or something. But see, you need matter to do that. You can't do it with light, because light is not a particle. Light is a torsion moving along a rope that interconnects any two atoms. Okay. Okay, next issue. I think this was the same one. Here's the second issue. Okay, replace the rope with two magnets. If one guy puts down his magnet, when does the other guy fall down? What is this fellow talking about? Well, he's talking about something I covered the other day, and that's this. Looks more or less like this. You have on the upper left, what you have is the Andromeda Galaxy. On the lower right, you have Milky Way Galaxy. And they're like 2 million light years apart. And here you have two guys in the middle of nowhere. You can say that they're on different planets, on asteroids, on whatever you want. They're 2 million light years away from each other. They're pulling on a rope. Okay, they're tugging on a rope. And, well, what happens? A little fella comes in there and cuts the rope. Okay, and so what happens is now the rope is cut. Okay, and the question is whether they fall instantly. Okay, which is what the rational science would tell you. And here's the version from mathematical physics. They say these guys wouldn't fall instantly. What would happen is the ropes would roll for 1 million years until the guy, it reaches the guy, and then he falls. And so the question is, what is that guy pulling on? What's at the end of his rope that keeps him pulling? In other words, what is he pulling against? And so this is the mathematical physics version. They say that when the mountaineer cuts the rope and the guy that's hanging from him, he doesn't fall instantly. It takes whatever number of seconds for that information to reach him. That's the mathematical physics. That's what they learned after 2,000 years. And so, the question now is, how do we do it with magnets? That's what this guy is proposing. He's saying, let's replace the rope with two magnets, okay? So the question is, what if they put their magnets down or enclose them at the last moment or whatever? What would happen to the other magnet? Would the other guy fall down immediately, or what would happen to him? Well, for this, we have to determine what magnetism is, and specifically what's going on between those two magnets. And I'm going to give you an idea here. You can do this test at home. Don't take my word for it, okay? Just take two magnets, okay? These are two magnets, okay? And I can already feel them pulling from me. There is nothing pushing my hand, nothing pushing on my hands. I can feel that my hand is being drawn, being pulled, like, when you pull on a donkey or a horse or whatever, you pull and the horse is not being pushed by the air behind him. He's being tugged by the rope in front of him. And this you can sense for your own self. You can see that it's already drawing. And that's not because, there are particles going through my hand, pushing on my hand or whatever. And so, the first thing you got to realize is that magnetism is a different kind of pull than gravity. Okay, and so here we illustrate it under the rope model again. All I can do is put you under the rope model. And this is more or less the swinging of the threads. Remember, magnetism is not done with ropes, it's done with threads. A lot of people have lots of time, it takes lots of years for them to understand that much. And all we're saying is, it's the threads that go around. You have all these domains within a magnet. They're aligned, and because they're aligned, the threads swing in the same direction, okay? And all I can show you here is a little more in detail. Here's the threads, okay? And the threads are going around. You see the arrows on the top give you an idea how they're swinging, okay? And these atoms, I put atoms there just to simplify the explanation. And you can see that the top part of each magnet is red and the bottom part is blue. That means that a magnet is not divided into north-south as mathematical physics has held for centuries. It's divided into top and bottom. It's the upper half of a magnet that's different than the bottom half. And what's different is that they swing threads in exactly the opposite directions. That's all it is. And they're aligned, they swing the threads. And so let's look at a couple regions here so that you can understand the mechanism. You don't have to believe it, you're just here to understand it. I'm not here to convince anyone. I just want people to understand what I'm proposing. I put a 1, 2, 3, and 4. So let's look at this, region number 1, okay? That's the upper left magnet, the upper right part of it, okay? And you can see what's happening to those threads. They're moving in a counterclockwise direction. And they're meeting up with the magnet on the right, the upper half, also on the left-hand side of that upper half where you see the number 2, and that's also swinging counterclockwise. So what you see is as the threads on the left magnet come up, the ones on the right magnet come down. And that's when they interlock, and that's how a magnet pulls on another magnet. The bottom ones do exactly the same, but in the opposite directions. They're swinging clockwise, okay? And so by doing so, when you put a magnet together with another one or getting closer and closer and closer, what happens is they interlock, the threads interlock, and they pull on the other magnet. And the closer they are, the more threads that intervene and the stronger is the pull. That's how a magnet works according to the rope model, okay? And magnetism is different than gravity. Both are pull, but they have totally different mechanism. So you cannot, the gravity is done with ropes. Magnetism is done with threads, and please try to keep threads and ropes separate. People don't always understand that. They say, oh, the rope theory or whatever. No, rope is a hypothesis, not a theory. Okay, and so let's look at this. Here what are the things that we have to explain with this? Because a lot of people say, well, we can explain with a field. But see, you got to explain exactly what a field is made of. That's the issue. And here you have a magnet underwater. And you can see how every iron filing is pulled up individually, okay, slowly, so that everybody can see it. You can see that it accumulates the iron filings slowly. That means something is swinging around the magnets and pulling those iron filings to the magnet, okay? And that's why, you know, we have a good reason to believe that the magnet has these threads swinging around. They pick up, you know, when they're swinging, they pick up the iron filings and draw them to the magnet and keep them there, because you got gazillions of these threads moving around. You got, you know, trillions of atoms in a magnet. And people don't always realize how many atoms we have in a magnet. We got tons of them, okay? And they're all swinging these threads. So you're talking about gazillions of threads. They're all swinging in the same direction because they're all aligned. They all form part of this thing we call, this region we call a domain, which is aligned. And they're swinging the threads in the same direction. So when one comes down, let's see if I can do it here. One comes down, the other one comes up, okay? And so they go like this, okay? And so they interlock and they pull. What happens when you turn one of the magnets around? Well, now they repel. Why? Because now they're both going in the same direction, okay? I'm sorry, they were going in the same direction here, right? Because this one's going in this direction, and this one's going in that direction. That means they're both going like this, okay? But now you turn one of them around, now they clash against each other, and now they push each other away. So we can explain both attraction and repulsion with threads, with the motion of threads. We can also explain why magnet attracts iron filings underwater, okay? So it's a different model. It works. Whether you believe it or not, that's your personal take, okay? Okay, just wanted to show that it's different than gravity, because we're going to talk a little bit about gravity today, okay? And so let me show you gravity here for a second. Okay, this is the mechanism we propose for gravity, again done with ropes, not with threads. And that's it. Every atom is interconnected, or one atom is connected to all other atoms in the universe. And when you have two objects, like in this case we got a cylinder and a box, or a cube, whatever, the farther they are apart, the ropes come together. They act as one. And the closer they come to each other, well, the ropes fan out. And that fanning out is the acceleration of gravity, okay? And so how does it measure with Newton's, alleged Newton's equation? Well, first of all, we put a T instead of an F because it's not force, it's tension. Okay, you need to understand that. It's not force, it's tension. There is a value for weight at each point in space, something which they call a field. Okay, and that means that weight is location specific. And then you have a big M and a little m, and that's the mass of one object, the mass of another object. And when we multiply those, we're talking about effective ropes. Effective ropes are ropes that are not pulling on the same axis. Okay, and that's what's happening on the right-hand side when you go from that far distant situation to the very close situation. Okay, okay. So gravity is done with ropes, but the ropes are tense. Okay, they're under tension, and they unite any two atoms. Okay, the closer they are together, the ropes fan out. That's the mechanism. Okay, that's different than magnetism, which is also an attraction, a force of attraction, but it's a little different. First, because it can do repulsion, which gravity can't do, and I explained that just now. But then it's the threads which come out of the ropes. Release these two threads when the atoms are spinning at great speeds, and you have these two threads running around, and now that's what's going to create the attraction and the repulsion, depending on the orientation of the magnet. Obviously, if the threads that are swinging are coming against each other, they clash, they push each other away. If they're both going in the same direction, when this one comes down, this one comes up. That's the mechanism. Very simple. Mother Nature's not complicated at all. Try to do it with particles, and I wish you luck. Okay, and let's see. I had something else here. Okay, so let's explain gravity dynamically. I have a little cartoon here just to illustrate it for you. Okay, we have the elephant falling to earth, and you can see what happens to the ropes. As he approaches the center of the earth, the ropes fan out from every atom on earth pulling on him. Not pulling, but every atom that suddenly has a different angle with respect to him. Okay, so we have more what we call effective ropes the closer the elephant is to the earth, to the center of the earth. Okay, so that's the mechanism that is proposed for gravity. Okay, also using the ropes, no particles here, none of that nonsense. Okay, and there was one more here, and I just want to show that there's a difference. Yeah. Here's a difference between the magnet and you just saw the gravity. Now here's the magnet. Okay, you have two magnets, and if they're going in different directions, clockwise versus counterclockwise, they push each other away. If you turn the magnet around at 180 degrees, and they're both going clockwise, then they attract each other. And more threads, the more they attract. If you turn it sideways, the magnet is, all you did was you didn't change the direction of the threads. It's only when you turn it 180 degrees that you change the direction of the threads, and now, yes, the magnets push each other away. Okay, and that's different than what you saw just now for gravity. So these are two different separate mechanisms. Okay, all done with a rope, thread, etc. Okay. We don't need particles here at all. You can't do it with particles. That's why they never have. They never could explain this, and that's why they gave up and said, we can't explain this stuff. We don't understand it. Yeah, because you can't understand it with particles. That's why. You can't produce pull with particles. I just challenge you to throw, a ball against a rock and see if the rock comes towards you. And good luck with that one. Okay. But with a rope, it's easy. You just pull on the rock. Very simple. Okay, and there was another question, and it had to do with mass. Let's see if we can get this thing up here. Okay, and the fellow says, my thoughts about what mass is. Mass is the number of atoms in an object. No. And again, don't take my word for it. When in doubt, you have to look for authority. People with great degrees, with celebrities, with big names, you got to look for big names. Otherwise, nobody will believe you. Okay, so here's big names. I'll put it on here on the side. And this is John Wheeler specifically. Edwin Taylor's also quite popular out there. Anyway, John Wheeler, I think he died a couple years ago, says, nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count number of atoms or by any other counting method try to evaluate amount of matter, that number would not equal mass. Okay? So please try to understand before one of us dies. Mass is not the quantity of matter as you've been taught in high school. And now here comes the bomb. Mass is equal to weight. Weight and mass are exactly the same thing. What are you saying, Bill? You're overruling thousands of years of understanding. Yeah, mass and weight are exactly the same. Let me tell you why. They're the same, and whatever they taught you in high school is wrong. It's not wrong, it's a lie. That's what it is. It's not wrong, I call it a lie. It's a lie because the way we determine mass is by weighing. That's the only way. We never count atoms. You take the grand kilo, which was used as a standard until recently, and which was a standard kept in Paris, France. And they had this kilo for hundreds of years, a couple hundred years, I think, or at least 100 years. I know it's in the 19th century, probably even before. But they had this grand kilo, and all kilos in the world were measured against that standard. And of course, they never counted the atoms that belonged to the kilo. What they did, they weighed it. And they said, okay, you have a kilogram. A kilogram of what? Of weight. That's what you have. Because it had to be weighed at a certain parallel, certain latitude, etc. They had to They had to weigh it under certain conditions because otherwise the weight would change. And yeah, we never count atoms. In fact, what would you count? Hydrogen atoms or uranium atoms? 92 protons versus 1 proton? Yeah, under the rope model, no problem. The unit of mass is the hydrogen atom, okay? Because there are no subatomic particles. No such thing, no such monster. These people have clashed things in their so-called accelerators, and they see some squiggly lines coming out of there, and they say, oh, look, that's the trace of a particle that came out of this explosion. That's their physical interpretation because they're thinking of particles. Only because of that. It's not that it's been proven, it's because that's their interpretation based on the particle model. But if there are no particles, that explanation, everything that's been done in the last 100 years with quantum mechanics is bunk, is nonsense. No, those curlicues that they see there are the ropes themselves that when they hit two atoms together or whatever they're hitting, you know, they accelerate all kinds of stuff there. But whatever they're hitting together, you get this mesh that's, you know, suddenly they're hitting something very hard at great velocity, right? And they are able to get, the system is able to capture some of these threads, and that's what they're because they don't take a snapshot. There's no such thing as a snapshot of that. You can't take a snapshot of a trace. And that's what they're saying they're seeing. That's what they're trying to sell you. They're saying, we took a snapshot of the trace of a movie. And no, what they did was they took a snapshot of a thread. You know, I take a thread. Do I have a thread? No, I don't. But I'll use the rope. You know, if you take this and it's twisted in some way, well, you can take a snapshot of this at any point in time. But that's different than saying I took a snapshot of a little particle that went from A to B, and I was able to concentrate all that, the entire image, in a single photograph. You know, that's a time delay type of thing, and that's what they think they're doing. Okay, so anyways, you believe what you need to believe. Okay, let's get on with Mr. Brian Greene, and today we're going to talk about space, his version of space. He put it in a documentary that went by the title of Fabric of the Cosmos, okay? And I think 2004. And so you can watch it. I think they have copies of it on YouTube, etc. So you can watch it if you want. And in the first installment, he talks about an hour about space. What is space? And it's just a monster. So I'm going to go through his analysis of how they concluded that space is not nothing, but space is something. Okay? But let's go first with the fatal problems, okay, so that you know what I'm going to talk about. I'm going to talk about the fatal problems of the notion of space that mathematical physics has, the notion they concluded with after 400 years of studying so-called physics. Okay, so here are the fatal problems. Okay, see if I can get this up here. Okay, and so here's the rundown. Space is both nothing and something, according to them. In fact, Brian Greene starts out by saying, if you ask someone on the street, right, and say, what is space? They would say, well, space is nothing. And he says, Brian Greene says, they would be right, but they also would be wrong. And then he goes on and does his rest of his documentary. And the question is, this is typical mathematical physics. You know, they always like these dualities. You know, they cover all the bases. They cover 1, 2, 3, and 4 in home base, the whole thing, you know, so everything's covered. Everything's yes and no to them. And so is space nothing or something? It's both. Nothing and something. Whenever they need the nothing, they talk about empty space. Whenever they need the something, they say, well, we bent space or space pushed, I don't know, the wall down or whatever. So they always use these dualities. Space is both. Nothing and something. And they never define either nothing or something. That's where it all falls apart. I mean, if you don't know what the word nothing means, if you don't know what the word something means, because you haven't defined those terms, or you can talk about nothing and something all day long and nobody can follow your presentation, because you can switch back and forth and say, empty space. Oh, what is he talking about? Is he talking about nothing or about something? And then he says, well, space, like in the Casimir effect, space pushes two plates together. So now it's an actor, it's something. And what is something? Oh, we don't know. So we don't have the definitions for these key words, and that's where the whole thing fails. Okay? Space is always treated as something. You're talking about bent space, warped space, space being bent by gravity. You get all this nonsense. And so they're always treated as something malleable, especially. Space is made of particles and also contains particles. And the question is, which? I mean, is space a container? An empty container that, like your trash can where you fill it out with junk? Or is space made of particles itself? And I've talked about the ether in the past. I got to bring that up because the ether is a good example of what people think of mathematicians, what they think of as being space. And here you have a picture of it. Is space infinite or not? Is space a container, the black stuff that contains all those little dots? And if you can see each one of those little dots, what contours each one of those little dots? In other words, tell me what the black stuff is. And if the black stuff is space, is it made of particles, just like the stuff in the center there? What is the black stuff made of? And they talk about empty space. So empty space is nothing? Is that what it is? And if it's nothing, what is nothing? What do you mean by nothing? And so this is the problem. We don't have definitions. These people are getting away with murder because they don't tell you what the definitions are. They just say, look, space is made of particles, or space is something. And you say, what is something? Well, we don't know, because they don't have a definition. What is nothing? We don't know either. But isn't it fun? Isn't it, we can keep rolling all day long with these words because they never define the key terms in their dissertation. That's the problem. Okay. Okay, so where does Brian start? Well, he starts with presenting a picture of what they think of as space, and he put this little prison, moldable prison, all these bars, and he's going to show that they move. He's going to be able to move these bars around. That's what he thinks space is. And the only thing I want you to concentrate on is what is the backdrop? What gives shape to each one of those bars, to all those lines that he puts in there. So here's famous space-time, or space, right? That he puts, Brian Greene illustrates space, math-viz, space is made of lines. So you got all these lines there. Okay, so that's space, okay? So the question is, what's the black stuff, or, that gives shape to those lines? That's the only thing we have to answer in mathematical physics. And they never answer that question, okay? Because they can't answer. They can't tell you what the backdrop is, what the stage that serves as a stage called space is. We need to find out what gives shape to space. And again, if you look at the ether here, just tell me, if spaces are the dots in the center because it's made of particles, because it's something, just tell me what the black stuff is that gives shape to each little particle. That's all I need to know. I need to know what the black stuff is, not the white stuff. White stuff is easy. The problem is the black stuff. The backdrop, and that's where you'll never hear an answer from them, because they say, oh, we don't know, we have no idea. But they know everything. They won't allow you to publish anything adverse, but they know everything. They've proven everything. It's a done deal for them. Okay, so here is space is nothing, he says, but he says empty space forms the fabric of the cosmos. Okay, and he says empty space is not nothing, it's something. Something with hidden characteristics as real as the stuff in our... I didn't catch that. Space is so real it can bend. Space can twist. Yeah, sure. And then it can ripple, okay? Okay, there's all these waves, the waves of space. Empty space forms the very fabric of the cosmos. That's his notion of space, okay? So now you know what space is. It's all these little lines, and the only issue again is what is the black stuff that gives shape to space, that gives contour to each one of those lines. And so he doesn't answer that question. He just plays around and says, see, we can move space around like if he can do anything he wants with it. Yeah, in Hollywood maybe. Hollywood, everything's so easy. The question is, do it on a blackboard. I want you to show me, what the black stuff is. If you're going to draw a line for space and say that's space, okay, tell me what the black stuff is. That gives contour to it. Tell me what the blackboard is. Okay? Okay, so where does he go from there? Well, the next point he covers is that the famous lie or nonsense talk proposed by quantum mechanics that an atom is mostly empty space. Absolute bunk, nonsense, poppycock. Here it is. And he says, even atoms are almost entirely made of empty space, okay, or empty space. And he says, space is everywhere. Space is the most abundant thing in the universe. What's a thing? Okay? Even atoms are almost entirely empty space. Okay? And you say, well, where did he get this? Was it a bad nightmare that he suffered one night? I mean, where did he get all this nonsense that an atom is empty space? Obviously, it didn't come from his tiny brain. All that this fellow did, he was just a little choir boy, an altar boy at a monastery, and they gave him a degree, and so he just repeats, he parrots whatever they taught him. So all he's doing is just regurgitating whatever went into his head, whatever he marked on the test, whatever he had to memorize. So he's got nothing of his own here, that he's proposing. No, the so-called empty space of the gut of an atom, that comes from Rutherford. In 1919, he ran a series of experiments. I think he ran them with Marsden, one of the, and Geiger, two of the guys that helped him. And they did the gold foil experiment where some of the particles that so-called particles that they shot at the gold foil bounced back, and most of them went through. And so because most of them went through, they concluded that an atom is mostly empty space. Well, we got a difference with Mr. Rutherford. I'm sorry to tell Mr. Rutherford, if he can still hear me out there wherever he's at. And here's the difference between Rutherford and Bill Gates. Okay, these are the different models of the atom. And according to Rutherford, he says that atom consists of a proton and an electron, and what's between them is empty space. And so the question is, what holds the electron bound to the proton? That's all we need. That's all he needs to answer. Because if it's only empty space and we got these two particles and there's nothing between them, not even a field, okay, what's holding the electron faithful to the proton? Why doesn't it fly away spontaneously? Under the Rote model, here's the 2D and 3D version. 2D version from David Robinson, great fellow who has been at the conferences. And Dan Ferguson, he gets credit for the 3D model. And you can see that's a little different than the model these guys are proposing, the mathematical physicists. All you have is the ropes converging on the electron shell, and that's where they separate. One strand goes straight to the center, and that's going to be, we call it the electric thread arbitrarily. No reason for that, just to be in line with the past. Okay, use the same language. And the other one, the blue one in this case, goes around and circles the proton star, and that's going to be the electron shell that encapsulates the proton star. And that's it. It's a different model. Why did the particles go through in the case of the gold foil experiment? Very simple, because an object is not that which you can touch or see. And it's incredible that in 2,000 years, no one has figured out that, light, gravity, magnetism, you can't touch and you can't see it. And so people concluded that there's nothing there. And so we have a nothing that causes something, causes a phenomenon, in this case attraction. No, of course, if you don't put something in there, you're in effect doing it with magic, your explanation. You're putting spirits in there. And that's what these people do. They put the word field, which is a concept. And they say, oh, we did it with a field. Yeah, but you got to tell me what the field is made of. Because the field is a dynamic thing that's already in motion, as we just seen with the magnet underwater. It pulls one iron filing at a time, this so-called field. So something is in motion. And if you don't believe me, take Mr. James Maxwell. He says, in that region field, there is exotic matter in motion. And Faraday was sided with him as well. He had a lot of experience with magnets, and he said, I cannot imagine these lines of force not being real, not being physical. So both of them said there's something moving in there that's physical, we just can't see it or touch it. So that's why, in neutron bombardment, they can go right through the atom, parts of the atom, not because it's empty space, but because an object is not that which you can touch or see. Okay? And people don't understand that because we're so used to our everyday 3D world where we can touch and see everything, and we say, well, if I can't see it, it doesn't exist. Not true. Not in Mother Nature's world. Mother Nature's world, we cannot see or touch. We're talking about invisible, intangible mediators. And so you're not going to solve them by going to the lab and running an experiment. There's no way, because you can't touch them, you can't see them, you can't detect them other than indirectly. The only way is to sit down at your chair upstairs, drink a couple beers, and think. Try to visualize how Mother Nature could be doing that magic trick. And you better put an object there because it's a mechanism. If I drop the pen and it falls to the floor, something came in contact with the skin of the pen. If a magnet attracts another and there's nothing there that I can't see, something came in contact with the skin of the magnet. And he who doesn't accept that is doing black magic, is saying the universe functions with concepts or with spirits. That's what he's saying in effect. So you have to put a physical object. You just got to make the invisible object visible. Okay, hopefully tangible as well, which is for sure not so easy. Okay, so Brian continues, and he gets his picture of space. And he says, look, we can see a picture of Spain, we can see a picture of Napoleon, but what does space look like? And he shows this little square and says, space, it looks like this, like nothing. Yeah, you're right, it looks like nothing. So how do you make sense of something that looks like nothing? Well, yeah, you can't, because it's not a something. But he turned it, or the mathematicians turned it into something. Why? Because, they said, we need to do something with space, because otherwise, what's the purpose of space? What do we do with space? They can't live with nothing. And partly they can't live with nothing because they don't have a definition of the word nothing. And science is very simple. If an object, something, that which has shape, nothing is the opposite. That which doesn't have shape. We're done. See how easy it was all these years? All you had to do was define these terms, and then you can use them consistently, rationally, scientifically. And so if space is nothing, what are these people talking about? They're saying that it's something. And you're going to see how they prove that it's something. That's the that's the fun part, okay? So so he says space is something. So now we know space is something. It's not nothing. It is nothing also whenever they need it, but it's something. And they're going to use the something part. They're never going to use the nothing part because they don't understand nothing. And so we ask some of the gurus, some of the popular so-called physicists out there, mathematical physicists. And here's one, and he says, what is space? We actually still don't really know. That's his answer. This is a PhD guy who's got many years in the industry, and he says, what is space? We actually don't know. Okay, we have another witness. Let's see what he says. Also another PhD, University of Maryland. He says, it was one of the deepest mysteries in physics. So these are the gurus, the people who know. You ask them, space-time? Oh yeah, space is blended with time because blah, 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 blah. And you say, well, what is space? Oh, we don't know. What is time? Oh, we don't know. We don't have a definition. So they don't know what space is. They don't know what time is. But they know for sure there's space-time, and space-time bends, and that's gravity. So we got a problem here because we don't have any definition. We don't know what they're referring to, but they already on the next level theorizing, saying, oh yeah, we blended these two thingies, whatever they are, these thingies, we blended them together and we created space-time. And then we marked space-time, and here's how we produce gravity. So all that part they know for sure, but they don't know what space is and they don't know what time is. They don't know what they're dealing with. It's like saying, you're playing with a toy and you're going through the motions because you say, this is what this guy hit that guy and so on and so on. And you say, but I don't see anything. Yeah, because there's nothing there, because we don't know what they look like. We don't know what they are. You figure it out. Okay. Here's another thing that shows that he's trying to get you to understand that space is something. Okay, keep that in mind, because that's his whole argument, that space got to be something, otherwise mathematical physics dies. Okay, so it's got to be something. And how does he do it? Well, here he's got a skater. Okay, imagine a skater spinning a completely empty space. Okay, he's taking all the matter out of the world. He says the skater feels her arms pulled outwards, but there's nothing in space. But his empty space is nothing. What is she spinning in relation to? Trying to answer questions like these, scientists came up with a bold new picture of space. Oh, I can't wait. And that key was to make something out of nothing. So they had to turn space into something. Here they had this nothing, and they turned it into something, because otherwise they couldn't explain this, why the skater's arms are pulled outwards when she spins, assuming she's the only thing in the universe. Why would her arms spin? Well, he concludes that it's space that's pulling those arms apart, and therefore space must be something. You know, on the it's known as Mach's principle, by the way, that all the stars in the universe somehow have an influence over us, physical influence. They're somehow tugging or pulling on us. That's what the skater's arms are spinning with respect to, the stars, the planet, the matter out there. With the rope model, open and shut case. All we have is all the atoms are interconnected. We're done. So when the skater spins, okay, all her atoms are, she's tugging in a sense against all the atoms in the universe. All of them. Okay? And so you need to picture that. Okay? And again, they're so far away that they don't affect her gravitationally. The table I have in front of me affects me more than all those stars affect her. But that doesn't take away from the fact that she's connected to all those atoms out there. Okay? So that's what you have to visualize under the rope model. Okay? So the next step, not only he wants to convince you that space is an object, something, instead of nothing, but it's real. So it exists, okay? And again, they don't define these terms. And here, again, he goes back to the skater. He says, well, let's start at the beginning in a second here. Okay, here it starts. Space is real, even though you can see or smell it, you can't see or touch it. Space is enough of a real physical thing to provide a benchmark for certain types of motion, like a skater. And he puts the skater there, and he said, Newton would say that she is spinning with respect to something. And she is, and that something is space itself. No. No, it's got to be with something. It can't be space, because space is nothing. She can't be spinning with respect to nothing. She can't be spinning with respect to that which has no shape. Okay? And so, yeah, the problem is that these people had to convert space into something. And we have a nothing, and they convert it into something. And the issue is, again, the definition. If you don't define the terms, your terms, we don't know what you're saying. So every time you say something or nothing, we have no idea what you're talking about. In rational science, very straightforward. Something, that which has shape; nothing, that which doesn't have shape. We're done. And so if it doesn't have shape, you can't say, well, this thing, no, it's not a thing. Because it's not a thing. Only that which has shape is a thing. So if this is doesn't have shape, it's called nothing, not thing. Okay? Let me say that again. It's nothing instead of not a thing. Okay? Yeah, nothing. That which doesn't have shape. So you can't say that nothing, in other words, that which doesn't have shape, hit the wall. You know, there's no surface there because it doesn't have shape. So you can't say that space does this and space does that, because space is a concept. Space is that which doesn't have shape. Space is not a physical object. You can't draw space, because if you could draw space and give us the shape of space, you would have to identify what gives contour to it. And it's just a monster. It just keeps going and going and going. What are you going to say? It's the fourth dimension within the fifth dimension within the sixth dimension? Is that the answer? You know, that's what string theory tries to do. They're inventing dimensions now. Okay, we covered that the last time. Okay, so they don't know what space is, but they know that space is interwoven with time, and here it is, okay? And this is what Einstein had to show. Space and time constantly adjust by the right amount so that no matter how fast you're moving, the speed of light always comes out to be 671 million miles per hour. In other words, they left the speed of light constant, which I don't disagree with, by the way, okay? Under the rope model, the speed of light is constant. It's got nothing to do with space or time, like these people say. But what they did was they blended space and time mathematically, okay? And they figured out that the speed of light is constant, though, so in their equation, they had to turn space and time into variables, okay? That's how they became malleable, and they became things that can be blended, you know, space with time, and create space-time. Why? Because they had to leave the speed of light constant. Well, under the rope model, speed of light is constant. We don't disagree there. The speed of light is constant and has nothing to do with space or time. It's got to do with the fact that a rope, you know, here I have my famous rope, and the rope has a certain number of links. And all you can do is change the frequency in exchange for the wavelength. So if I make the links longer, I have fewer links. And if I make the links shorter, I have more links for the same amount of rope. So that's why light is a constant. It's got nothing to do with space or time. But in their calculations, they had to shrink and expand space and shrink and expand time to accommodate light. That was their solution. Okay, and that comes from my dear friends Fitzgerald and Lawrence. These fellows, they played around with math so much they went nuts. They really misinterpreted everything so badly, and only on the basis of particles. Without the particles, if that dies, they're dead. Okay. Okay. Now, one interesting point in his Brian's. In his show was that he put this. He showed that the moon goes around the sun, the Earth, right? The moon goes around the Earth, and he says it's like if it's tied by a rope. And I said, oh, I like that. It's tied by a rope. So what's the problem? And he says, but they dismissed that immediately. They said we knew that could be right. And here it is. Says, how does the Earth pull on the moon across hundreds of thousands of miles of empty space? Okay? And he says, they behave as if they're connected by some kind of invisible rope. But everyone knew that wasn't true. Well, there they had the solution. They actually had the solution to all their problems. If they would have thought of some connector, some physical connector, they wouldn't have had a problem, because that's exactly what we see between the Earth and the moon. The moon swings around the Earth like the Earth swings around the sun, because every atom is from one object is connected to the other object. So if the Earth has gazillions of atoms and they're all connected to the gazillions of atoms that comprise the moon, you can see why the moon doesn't fly away, because it's physically connected to the Earth, just like the Earth is connected to the sun. And here's the illustration of that so that you can see it, okay? Okay, so the Earth twirls the moon around because every atom of one object is connected to every atom of the other object. So he was right, but somehow they rejected it. Here it is again. It says they behave like they're connected by some kind of invisible rope, but everyone knew that wasn't true. Why did they reject it? They had no reason to reject that. Instead of pondering that possibility, they rejected it offhand. They said, no, it can't be. Why? Because they couldn't see it or touch it. See, touch is the problem. That's the problem. Everybody asks me about the same thing when they come across the rope for the first time. How come we can't see it? How come we can't touch it? How do they go across? How come they don't tangle? They're always concentrated on see and touch. They never realized in the last 2,000 years that Mother Nature specifically made the mediator she uses for her daily chores. She made them invisible and intangible. So don't ask to see or touch them, or why they don't go across, why they don't get tangled or whatever. You can't ask those questions because she made them invisible, intangible. And we're not used to that. We're saying, well, hold it. If I have two ropes, hardware store rope, and I try to put them across each other, they won't go across. No kidding. Why? Because those are objects of our everyday life. Can you see or touch the mediator of light? Can you see or touch the mediator of magnetism? Here I have two little magnets. Okay, I always show these. Okay, see if I can do this. Okay, there's something in between them. And I can't see or touch them. I can't touch it. Nothing in there. And I can't see it either. Can you see anything between them? And something is there because we don't see it or touch it, but something is there because it creates this effect. And if you don't accept that, you're doing religion. What you're doing is spiritualism. You're doing it with spirits or with energy or with mass or who knows what, with nonsense, with concepts. No, you need to have a physical mechanism to explain that. And for that, you need to have objects. You can only explain physical mechanisms with objects. Okay, and good old Brian, he continues and he tries to show you again that space is a physical thing and that they've proven it. They don't know what it is, but they've proven it that it's a physical thing. And for this, you got to invoke authority. And what more authority than Mr. Einstein himself? So according to Einstein, the secret to gravity, space-time could stretch like an actual fabric. Okay? And let's start it here again. Give it a second. It says, according to Einstein, the secret of gravity lay in the nature of space-time. And so he's going to play around with space and time. He's going to move them around. He's going to bend them, whatever. And that's going to be the cause of gravity. Space-time could stretch like an actual fabric. Okay, so they're not talking about, he's not talking, Brian Greene, in his documentary, he's not talking about, something abstract. He's saying, look, I can explain gravity to you. I can explain why the Earth doesn't run away from the solar system because space-time is bent. And if it's bent, it creates this depression. The Earth rolls around this depression. And some people can't understand. They say, no, that's not what general relativity says. Yeah, that is what general relativity says. What do you want? I mean, am I supposed to bring Brian Greene in person to tell you that? I mean, he's telling you that it's a warping of space-time, that gravity is geometry. It's a geometry of space-time. The bending of space-time creates a depression, and the little balls just have no choice but to run around. And in fact, he illustrates it in this way. Here he shows it. He puts a bowling ball on a pool table. And here it is. And then he's got the moon rolling around the Earth. Why? Because there's a depression. And so the moon doesn't fly away because there's a wall of something, of space-time, of warped space-time that prevents it from going out. So he puts the bowling ball in the thing, in the pool table. He sinks it, and now he's going to roll his ball around. Why doesn't the ball go out? Because it's going around a hole. That's why it's going around a depression. So there's space-time coming in contact with the surface of the moon. That's their explanation. That's their physical interpretation of their equations. So people don't understand that. People say, no, that's not what Einstein said, or that's not what Brian Greene says, or that's not what the mathematical physicists say. Yeah, that is exactly what they're saying. They're saying that the moon rolls around because there's a depression. It's rolling around the ring of a depression. That's the explanation. Okay? And so, people accuse me of, raising straw men or attacking who knows what, They're saying that that's not what general relativity says. One guy said, because I told him there's a wall of space-time coming in contact with the moon, according to Einstein, he said, no, that's not true. Where did you get that? There it is. You got it illustrated. And of course, these people will usually dismiss that and say, well, that's just an analogy. An analogy of what? I mean, tell me the mechanism. If that's not if that's just an analogy, it's an analogy of what? What is the cause? Why doesn't the Earth fly away? You got to explain that. If you're going to say that the Earth rolls around a depression or the moon rolls around a depression caused by the Earth, well, that is your explanation. So that's the real explanation. Don't tell me it's an analogy, like saying, well, this is how we try to get by. You either get by or you don't. Either that's the way it works or it ain't. You can't have it both ways. So it's not an analogy or whatever word you want to use, or metaphor or whatever. In fact, I've got another one. All this comes from the documentary, by the way. He does use that word metaphor. He says, no, it's not a metaphor. In other words, this is what they're saying, okay? Just to illustrate it, you've seen a roulette at the casino if you've ever been there, okay? That's why the moon doesn't fly out of the earth, or why the earth doesn't fly out of the solar system, because it's rolling around a depression, a wall that prevents it from leaving the solar system. That's why, okay? So that's the mechanism proposed by general relativity. Now you're an expert. Just show them the roulette and say that's exactly what Einstein explained. And if they say, well, that was just an analogy, tell them, okay, tell me, why does the earth fly out of the solar system? If that's an analogy, what is the real super duper explanation? What's the mechanism? Okay, very simple. Just explain it to me. If that's not it, tell me what is. Okay, very simple. I mean, if they've already discovered that space-time exists and it's bent and it's gravity, hey, you tell me what the mechanism is. Okay. Okay. So Brian continues. He tried to explain to you that space is an actor. It's not a passive observer. It's an actor in everything that happens in the universe. And here he shows it. He says, where Newton thought space is passive, Einstein thought of as dynamic. Okay, it's interwoven with time and it dictates how things move. After Einstein, space can no longer be thought of as a static stage. Okay, it's an actor and it plays a leading role in the cosmic drama. Okay, so space is not a nothing. Okay, space is a something. It's a something that moves planets around or affects the behavior of planets. That's why the wall of space is the correct analogy for what general relativity proposes. The reason the moon doesn't fly out of the Earth orbit or the Earth fly out of the solar orbit is, according to general relativity, it's because there's a wall of space-time blocking its escape. That's it. It's the roulette mechanism. No analogy, it's the real thing. And if they say it's analogy, okay, tell me what is. Don't tell me what ain't. Don't tell me that's not what general relativity says. Tell me what general relativity does say. What is the physical interpretation? Don't give me equations. I want the physical interpretation. Okay? Don't go around me. Okay, another way they prove the existence of this is through the black hole. Obviously, they had to introduce the black hole because that's so popular, right? And so he says, according to Einstein's theory, a spinning black hole can literally drag space along with it, twisting it like an actual piece of cloth. How's that? Okay. So a black hole bends space-time and twirls it around and drags it with it wherever it moves. Okay. So yeah, according to mathematical physics, especially general relativity, space is a real thing. It's a real thing. It's a physical thing. It's not nothing. I don't know what empty space means. Again, have no idea what that means, because they would have to define what empty means. What do you mean empty? Empty of particles. What's left? A can. You took the trash out of your trash can. You left just a can, empty can. Is that what space is? Some kind of container? Is that what space is? Or is space itself made of particles? Is it infinite? Is it finite? If it's infinite, how do you know it's a physical object? If an object has to have shape, what's the shape of an infinite object? And again, we have all these questions that they never touch because they say, well, that's philosophy. They dismiss it as philosophy because they can't explain it. That's why you got to explain it to a 10-year-old. If you can't explain it to a 10-year-old, you don't know it well enough. Who said that? Einstein. Okay. And so here we get to the last part of his documentary. Says, is space something? Well, space actually dynamic, active, and flexible. We'll wait for the next one. Is space actually dynamic, active, and flexible like a fabric, or is this just a metaphor? Does it actually describe what space is? Okay, so is space real or not, or is this just a if it's pushing planets, obviously it's got to be real, right? So they had to test this, okay? And how did they test it? Well, what they did, they ran a project known as, NASA did, right? NASA said, we're going to run an experiment using gyroscopes. And they put it on this rocket, and this thing went up in the air out there. And what they did, they had it orbiting the Earth. And these were super duper gyroscopes, very polished, very round, the most perfect balls ever built here on Earth, according to them, which is good for developing technology, nothing wrong there. And they sent them out into outer space, and they wanted to see if the gyroscopes were dragged around. In other words, if they changed their orientation because as the Earth turned, right, was it dragging space with it? And if the gyroscope was out there in space, it would notice that dragging of space, okay? That's what they wanted to show, and they showed it with this project known as Gravity Probe B, okay? And so here's Gravity Probe B. This is what he puts in his documentary, okay? So it's, let's start at the beginning. Give me a second here. There we go. NASA's Gravity Probe B project was designed to measure how much the Earth drags space around itself. You can see dragging space, right? Okay, and then, however, the gyroscopes were experiencing an unexpected wobble. Okay, they were wobbling. It took 2 years to clean up the data. You know what I mean? Wink, wink, nudge, nudge. The results showed that the axis of the gyroscopes shifted by the amount predicted by Einstein's equations. No kidding. They always confirm everything their preconceived notions. They already confirmed them. Obviously, they had to confirm them because this project cost them millions of dollars. So they had to confirm their theory, for otherwise, a lot of people would be out of work. So it's like the wolf guarding the sheep here, situation. Anyways, yeah, the Gravity Probe B confirmed that Earth drags space around, drags nothing around. I wonder if it dragged empty space or just a typical relativity space, the one made of particles and elastic, and that is a fabric and can be warped and bent and twisted and rippled. So I'm wondering which space it pulled around. Hopefully it wasn't the empty space, because I don't know how you're going to grab that empty space to twirl around yourself, okay? Okay, so, and obviously they always prove these things. Confirmed. You can't even argue against it, okay, because they proved it with experiments. Okay, and here's the last bit. It wasn't enough to do general relativity. You had to do a little quantum to show that space is really not only something, but it's made of things, okay, made of particles. Once you get down to this size, the world plays by a wildly different set of rules. You're talking about the subatomic world. According to these rules, even if you try to remove every atom and particle, you'd find that empty space still has something. Particles are appearing in and out of existence. They erupt out of nothingness, quickly annihilate each other, and disappear. It says, this is the realm of atoms and subatomic particles. When you get down to this size, the world plays by a different set of rules. According to these rules, even if you try to remove every atom and particle, you'd find the empty space is still far from empty. Particles are appearing in and out of existence, and they erupt out of nothingness quickly and annihilate each other and disappear. So this is the world he's explaining. He's saying that space itself is made of particles. And the only question he's got to answer is, if those are the particles that make up space, what is the black stuff that gives contour to each one of those particles? That's all he's got to answer. So he didn't treat that subject in his documentary. That was unfortunate. And yeah, no mathematician will ever do that, because they say, well, now you're entering in philosophy. No, I'm not. You just told me that space is made out of particles, okay? Fine, complete your assumption, complete your hypothesis. Tell me what contours each particle. And what we have here is a double talk. That's what it is. It's these people are telling you, look, we understand how everything works. We proved it. We've got the equations. We ran the experiments. We have the data we measured. You know, we got the data. And so based on that, they say, we know. And then when you ask them, oh, what is space? Oh, we don't know. As you just saw a couple witnesses there, high-level witnesses saying, we don't know. We don't know what space is. But they know everything around about it. We know we can drag space. We know we can kick it, bend it, twirl it, ripple it. We can do a lot of things with space, but we don't know what it is. It's like we're handling a monster we can't see. And what does it look like? Well, he showed you what it looks like. It looks like nothing. And so what they had to do was turn that nothing into something so they could make some use of their equations, because otherwise their equations wouldn't work. That's what the problem was. So they had to turn space into something, which is exactly what the Aristotle did. Also, Aristotle, you know, he turned space into something. He said there is no such thing as empty space or an empty void, because as soon as it becomes empty, something fills that space immediately. And so he saw this as a train of particles occupying locations that some other particle just left behind a split second ago. And what's the problem with it? The problem is that if you have a discrete object, you know, contoured all around here, like a ball here, okay? And let's see what I can use. Oh, I can use this. You have a ball. It's contoured completely all around. You can see this ball completely. You know, it stops there. It doesn't continue forever. It stops there for whatever reason, right? And here's another object, and it stops there. Well, if the ball moves and the cup occupies that space, no problem. I have no problem with that. But each one of these has shape to begin with, and they don't have the same shape. And so obviously, if this one goes out and this one occupies its space, it's that same space. Well, obviously, we have to explain, you know, what's contouring these two things. And that we call space. And he said, no, Aristotle said, no, that space is filled with particles, with invisible particles we can't see. And that's essentially what all these people have concluded after 2,000 years. They came up to the same conclusion. They said, look, there's no such thing as empty space. There's no such thing as nothing. They couldn't use nothing, first because they didn't define the term, so they don't know what the word nothing means. But second, because they needed space to be something in order for their equations to come out right. Otherwise, their whole discipline falls apart. So the day the people discover that the emperor has no clothes, these people are dead. We're going to shut down everything. So hopefully nobody listens to me. Because we're going to turn CERN and SLAC and Fermilab into white elephants. That's what's going to happen. Yeah, they had to turn space into something in order to carry out their equations. Without space being something, they die. All of mathematical physics collapses completely. And first it was called the ether, then they found that, at least they thought they proved it with the Michelson-Morley experiment, that there was no such thing as ether, and so they invented space-time, and they said, well, what is space-time? Well, that's an equation that we use where we have all these four coordinates that pinpoint an event that happened in space-time. So they turned the thing around. They said, look, space-time's not like a body. It's the four coordinates we need to locate a point within space-time. What is a point? An event, right? And that's how we describe it. But then they went back and they said, well, how do we explain gravity? Well, now they had to turn space-time back into a physical object and say, well, we have this ball weighing down space-time, it bends it, and then another ball rolls around it, and that's gravity. So they had to turn space-time back into a physical object. And that's all you have to ask them, is space, in this case, right, a physical object? And what is a physical object? Please define the term, because obviously it's very important if they're going to say that space is something. Okay, with that, I'm going to see you on Sunday, and hopefully you have a good weekend. We'll see you then. Bye-bye.